All right, so let's go through all three of these, A, B, and C. So we have a velocity time graph. This is for an object moving in a straight line. So here's what you want to think about. So we got let's say it's a car, or let's just say it's a dude. It's a guy, okay, and to the right is plus, to the left is minus. So look, when this graph begins, the graph begins right down here. Which way is this guy moving at the beginning of the graph? To the left or to the right? To the left, because these velocities here are what? Negative. And what does negative mean? To the left. So this guy or car or whatever it is, when the graph begins, he's moving to the left. When does he reach a velocity of 0? When does he stop? At 10 seconds. He stops right here, so that now he's over here somewhere, right? So V goes to 0, and then what happens at 10.1 seconds? Right after 10 seconds, what happens? He starts moving back to the right. Okay? Hey, just looking at this graph, where is this guy going to end up?
Same place.
He's going to end up, he's going to come back right to where he started. How do I know that? Because what type of graph is this? Velocity versus time. What's the area under a velocity time graph? Displacement. So look at this area. This area here is what? Plus or minus? Minus. That's negative. And then this area here is what? Plus. Are these areas the same or different?
Different.
The same. This area here and this area here, they're identical, which tells me his negative displacement and his positive displacement are the same. So the guy walks out, he goes out a negative displacement, and then comes back the same positive displacement. Does that make sense? Okay. So what are the questions? Find the average acceleration of the object during the following time interval. So how do you do these? So from 0 to 5. So 0 seconds. 0 seconds is here. 5 seconds is here. What's the how do you get acceleration on a velocity time graph? It's the slope. So what's the slope here?
0.
0. And why? So that's the average acceleration is 0. And why does that make sense? Because what happens from 0 seconds to 5 seconds? Does he change velocity?
No.
No, he stays at 8, 8, 8, 8, 8, 8. He's 8 meters per second the whole way in the negative direction. He doesn't change velocity. Okay, how about from 5 to 15? From 5 seconds, which is here, to 15 seconds, which is there. What's his average acceleration going to be?
1.6.
It's going to be the slope. So what you do is you connect those 2 points with a straight line. Boom. Take the slope of that, and that's his average acceleration.
1.6.
Is it 1.6?
Yeah.
Okay. All right, how do you do part 3 here? Part 3, from 0 to 20. So 0 seconds is here. 0 seconds is there. 20 seconds is there.
You connect those.
The easiest way to think about it, you connect those points with a straight line. Take the slope of that line,
0.8.
and that's the average acceleration. Matt? Sure.
0.8.
Okay, 0.8. All right, answers are in the back. Answers are in the back. But that's how you do it. Okay, B. Find the instantaneous acceleration at 2 seconds. Okay, so 2 seconds is right here. So how do you find instantaneous? You draw a tangent line. Now, this is really nice because look, the tangent line is this line. So what's the slope of this line right here?
0.
0. That's the instantaneous acceleration. What's the instantaneous acceleration at 10 seconds? So 10 seconds is right here. Well, draw a tangent line. It's the tangent line is the line, right? So that should be 0.8. Same thing.
Or 1.6. Or
Well, whatever the slope of this line is right here. So what's this going to be?
1.6.
It's going to be, looks like it's going to be about 8 over 5. What's 8 over 5? 1.6. The slope of that line is 1.6. Okay, so that's instantaneous. Okay, part C. Oh, well, what I did is if it's a straight line, you can use any 2 points you want. So I used those 2 points. So the rise here is 8. The run is 5.
Okay.
You know, when it's a straight line, you can use any 2 points. Any 2 points on the line. Okay, C. Find the approximate oh, notice I changed this. This says distance in your handout. I changed it because that was a typo, right? It's kind of a nitpicky thing, but you know, displacement can cancel. Distance can never cancel. You guys remember this? Like, look, if you start right here, if this is your start point, and you go out and back again to the exact same point, what was your displacement? 0. What would your distance be? The distance would be however far you went. Okay? So I changed this to displacement, and that's what I'm using for the answers in the back. Okay, so find the approximate displacement of the object during the following time intervals. Okay, so from 0 to 5. So how do we do this? So from 0 seconds, from here to there, how do we find displacement on a velocity time graph? It's the area, right? Should I show you again why that's displacement? Because look, how do you find area? The way you find area is you go what? Base times what? Height. Okay, what's the base measured in? This base, the base is measured in what? Seconds. What's the height measured in? Meters per second. What happens if you multiply seconds by meters per second? They cancel and you get meters, which is displacement.
Wait, so for those ones, do you just use the formula like x equals 1/2 velocity final plus velocity original times t? You use that.
That's pretty much what you're doing.
Okay.
Yeah. Yeah, you're going x equals 1/2 v final plus v initial. Because look, what is 1/2 v final plus v initial? What is that? That's the average velocity. Right? If you add up 2 things and divide by 2, that's the average. And then multiplied by t. All right, so you're taking the area here. So what's the area there? The base is 8, the height is 5. That's 40, negative 40 meters. Negative meaning to the left. Okay, let's just do one more. What is the displacement from 5 to 15? Ooh, look at this. So 5 to 15. So look, we got 2 areas here. This area down here is what? Negative. This area up here is what?
Positive.
Positive. Are those same areas or different?
Same.
Same. So what are these 2 displacements going to do? Cancel. It's kind of like this. From 5 seconds to 15 seconds, the guy went out to the negative, right? And then what did he do? So at 10 seconds, he stops. So here he is at 10 seconds. He stops. Then what does he do from 10 to 15? Goes back positive, right? And those 2 are equal, so they cancel. So the answer to this one is 0. You get that? All right, 10 to 20. This will be the last one, I promise. So 10 to 20. So what do you got to do here? I'd break this into a triangle and a rectangle. All right, so the area of that triangle is going to be 5, that would be 20. The triangle is 20.
40.
40. So the total is positive 60.
It's 0 to 20 there.
Okay?
0
All
to
right.
20. Is that 10 to 20?
10 to 20, that's the last one.
Well, you put it next to 0 to 20.
Oh, you're right. It's that one. Oh, yeah, what was I doing? So it's 0 to 20. So look, yeah. This one is positive 60. This one, oh man, you could just do this in your head. What's this one going to be? 0. Because look, 0 to 20, that's the whole thing. That's the first one we did. Boom and boom. This area and that area cancel.